Okay, so you are all set up and ready to weld this joint. Your machine is set up correctly, your torch is assembled and ready to rip. Looking at this joint here, you would assume it would be smooth sailing with welding it. So let me tell you something that an old welding mentor taught me back in the day. And this is going to save you from a world of trouble. Look at this joint here. For the sake of an example, we are using a fillet joint here. But this can also occur and cause bigger trouble with something like square tubing, coped pipe joints. And this can be an even bigger problem with more elaborate joints like this here, or fabrication projects, for example. Okay, so what I'm looking at here is the actual tack welds themselves. Take a good look at this one right here. We have some decent filler material here for sure. We got a good amount of heat that's been used. This seems okay. So what exactly is the problem here? Well, to put it simply, these suckers are gonna break. Let me ask you a question. If you have ever TIG welded aluminum before, more specifically, you tend to see this with something like fabrication projects. What is one of the most annoying and common problems that you have to deal with when welding it? Distortion. If you have experience with TIG welding aluminum, you know that aluminum flexes and warps so much as you weld on it. Look at this example here as I am flashing up and welding on this joint. Boy, oh boy, that moved. So if you're set up to weld and you only have a couple little cuties like this holding your project together, as you flash up, the heat, the distortion starts to do its thing. This poor little fella here is gonna be hanging on for dear life. And, oh nuts. Now when you finish, the piece could have shifted and come out of square from when you tacked it. This can also shift alignment and this can block penetration into the joint. These problems that you're gonna have to deal with suck. Now, like I said, especially if you're working with something like structural tubing or something like that, a tack popping can cause a gap to form, pieces can shift and twist, so a project that you may need to stay really flat can now have a twist in it. And obviously as pieces get longer and longer, this twist can compound. This causes big problems down the line. And with even more intricate and elaborate joints, obviously down the line, this can have massive consequences. I've got a couple things here that are gonna help to make sure this doesn't happen. And distortion is not gonna cramp your style at all. Okay, watch what I do right here. As I'm getting ready to weld, I'm basically set up with the exact same posture and position that I'm gonna be welding in. I'm literally gonna tack this up as if this was my actual pass. I'm not using one of my hands to hold something in place. If you need to keep your piece stable as you tack it together, you can use a little blend tack just to get started. Or like I prefer doing, I like clamping pieces in place. Okay, check this out here. Now, I am arcing up and I'm giving it good heat and good filler as if I were starting out with my actual welding pass. I'm watching for my filler to blend to both plates here. We don't see any hard edges or any lack of fusion. And now watch this. This is what I call two-stepping my tacks. After my first tack is done, and then actually this is usually where people tend to arc off and finish the tack. What I'm gonna do here is after everything is good to go, after the first tack we did here, I'm then gonna take one step forward in the direction that I'm going to travel, and this is so important. Then what I'm doing here is my second part of the tack. I'm basically doing the exact same thing with the first part, but I'm doing it one step forward in a second puddle here, and then when everything looks good, I am then going to extinguish nice and slow. It's only a tack weld, but I treat it as if it's an actual welding pass. Now let's take a look at our little buddy here. This is going to be drastically stronger and more resilient when distortion occurs. This is going to hold your piece much more securely, and this is not going to allow things to shift or lose alignment as much as you are welding elsewhere on the project or joint. There's also other reasons why this two-step tack is going to help you immensely. Check this out. Again, I go over all this stuff in my online TIG welding programs. My students have learned how to actually apply this tacking exercise that we just talked about here to some real projects. And yes, these are real fabrication projects that my students have built. Obviously with some of this stuff, we can't have any distortion at all. The lessons in my program are going to teach you how to deal with stuff like this, like distortion and tacking, so that you don't experience these problems and you get your projects done much easier with better results. Go enroll in my programs right now. You're going to love them. I even have multiple free classes on my website. Check them out. But look at the details of what we want to look for with just the tack itself. We can see here it has got decent filler material into it. It is not overfilled, which is very important. With overfilling, sometimes we can see hard edges where the filler material meets the base material. You'll see lack of fusion, but with this example here, we see the filler material blending in nice and smooth, no lack of fusion, etc. For tacking a project together, this is exactly what we want. We can also see the profile is relatively concave, which means that as we weld over it with our actual welding pass later, there's not some stupid dumb bump that we have to weld over and it's going to create inconsistency with our welding. That's very important. Taking another look at it here, we can also see that this finishes up with this little pocket right here. This is going to be a great place to start your pass or even finish it. You're going to be able to do so without melting the end of the joint completely. Now remember, this joint or project, whatever you're doing, if it's under any stress after tacking it together, this could potentially be holding the alignment of your entire joint. If you melt this little bit at the end all the way, the joint can shift, it can pop open, lose alignment, just like we talked about earlier. Now on top of our two-step tack being stronger overall, like we talked about, it's actually going to do something that's extremely valuable with more elaborate fabrication projects or things that need to stay square or in dimensional check. After you finish a two-step tack, this is actually going to show you what is going to occur as far as distortion. And again, this all happens before you do the actual welding pass. How's about that? This little cutie here is going to show you exactly what you're going to have to deal with it, and you can fix it before you attempt the full pass. You can look at the joint, you can potentially see if it has f***ed off in one direction or the other. You can go ahead and correct it and fix it before running the complete pass. And you have just saved yourself potentially so much trouble. That's right, put that giant hammer away. We can fix this problem without touching that thing. Now, speaking of exactly this, you can now anticipate what is going to happen ahead of time at this point here. And what you can do after assembling your project, doing the two-step tacking procedure that I have described here, you can do something that I tend to refer to as pre-flexing. Make up whatever name for it you want, I don't care. Now that our two-step tacking has shown us what is going to occur as far as distortion, or how much things are potentially going to flex as we start welding, what you can do is then tack your pieces together with this amount of distortion in mind, and you can literally outsmart this amount of distortion to some degree. You can mitigate a ton of this as you start out with your tacking procedure, even before you get welding with the actual welding on your project. You can then take an educated guess about how much it potentially might flex even as you start out the actual welding procedure. You may be able to lean things in the opposite direction that you know they're going to pull a little bit as you start welding. I think you can really understand how important this little thing is to do properly, and not only how to do it properly, but how to take a look at the results and really break down what you see so that you can understand what is happening or what's going to happen later in your weld out. A lot of this stuff can be taken care of at this point before it actually happens later, and you're kind of handcuffed to the results that you have or hitting stuff with a hammer because you've fully welded everything. If you are going to consider where the pocket is going to direct your welding, whether it is a start or a finish to a pass, in some cases you can actually take your two-step tacking procedure and you can point these pockets in specific directions. For example, if you are doing an intermittent stitch pattern like this here, you can do your tacking procedure so that the pockets point towards each other. After the tacking procedure, you'll be able to see and correct how much distortion has occurred. And then again, your welding is going to take place in these pockets here, and it is going to leave the stuff on the outside. This is going to help to bolster and keep your welding project a little more stable, and distortion will occur much less. Again, take a look at this silly thing here that literally took us 5 seconds to take a look at and break down. I have free online TIG welding classes on my website. You can learn from home. Go sign up for a class. They are on demand. You can watch them whenever you want, as many times as you want. Do a random act of kindness for a stranger today. I am Dusty James. Phil and Chill. We'll talk soon. Peace.